All right, this is a video about a problem I found with the ICOM IC-7100, which is also affecting the IC-7300. These are two very popular model radios. I'm going to first show you a video of the problem that I'm hearing, and then I'll show you areas of the schematic which are responsible for this problem and why it particularly affects the IC-7100 and 7300 and not some other models. And then finally, I'll show you a modification that I did that completely solves this problem. We have a DC supply here. This is a linear supply, really big. We have it going to the radio. We have the thing that they recommended you install, and then the head unit here. And so this is what I'm seeing. There's nothing connected to it. And before you start saying, oh, it's interference, just wait. So watch. For one thing, this is with AM. With preamp 2 is where I've got it, although it'll do it with no preamp. So I'm gonna right around there. Okay, now watch this. If I turn the volume down, it stops. It's just barely there. I turn the volume up. It gets bad. Now watch this. Before you say, oh, it's interference. Watch. 11.9 volts, right? I go up a little bit. And now, it moves up. Go up a little bit more. And now, moves up, right? So let me show you something else. We'll get this back down to 11.6 or so, something like that. Okay, so I'll move this up a little bit to 11.8, let's call it. It's just so we have something even. It's an even 700. So now I'm going to go to 1400. Come on. I hope you can hear that. Right? And I'll go to 2100. Yeah. And again, it's you turn the volume up, it gets worse. Turn the volume down, it gets not so bad. So that was 21, here goes 28. It's there. Now we'll go to the next one. Here at 35, it's really bad. And again, interference does not do this, right? And once again, just to prove it, I'll go up. This is 11.8 volts. I'll go up to 13.4. And frequency goes higher, right? All right, I am at ham radio outlet looking at the ICOM 7300, and it also has the problem. It's higher frequency here, 862. So that means, let's see, roughly 1700 would be the second harmonic of that. That's an AM radio station, it seems like. But the odd, yeah, there it is. All right, well, let's first take a look at the ICOM 7100. This is the service manual. It is page 10-3. This can be downloaded. Just Google ICOM 7100 service manual and you'll find it. And so the particular area that is involved is down here I'll zoom in on it. It is this here, IC-221, which is this MP-7741. What this is a PWM audio power amplifier. And it runs at an average of 700 kilohertz, but the frequency that this runs at depends on the power supply. What about that? So as the power supply increases, the frequency increases. As the power supply decreases, the frequency decreases. The manual for the MP-7741 states that very clearly. So that's what's happening here. This thing is just oscillating just in its normal PWM fashion. And when it does that, you know, it's a radio receiver, and the radio receiver picks up that oscillation. And since it's a square wave, it picks up really typically odd multiples of that. The odd multiples of the oscillating frequency would be the worst. But, you know, once you get near it, the audio kind of gets into this feedback thing by virtue of the power supply. And it will start spitting out some stuff on even multiples of that as well. And so I was wondering what, you know, I have an IC-7600 as well. I was wondering why it doesn't affect that. So I'll show you why. Okay, so this is the service manual for the IC-7600. This is page 10-7. We will zoom in on the relevant area, which is this here. LA4425A, which is a 5-terminal chip made by Sanyo. This is a linear power amplifier. And so since it's a linear power amplifier, it's not PWM. It doesn't do this switching thing. And for that reason, it's just simply very quiet. It doesn't create this audio noise. So what I'll do now is we will transition to the service manual for the IC-7000. If we zoom in on this area here, let's see, this is page 11-5 of the IC-7000 manual. We'll zoom in on this here, and what we can see is that it also uses the LA4425, which is an analog power amplifier. It's not PWM. And so this has been discontinued, actually. You know, obviously the IC-7000 is a very old radio. The IC-7600 really isn't that old, but it must be of kind of an older generation per se, because you know, this chip here made by Sanyo has been discontinued. I'm sure they have enough of them to continue production, and you can get these things on eBay. Although they have been discontinued, you could still get them. But that's why the IC-7000 and the 7610 do not have this strange oscillation problem. So now let's take a look at the 7300 service manual, which is here. And let's see here. This is page 10-4 of the IC-7300 manual, and we'll zoom in on the relevant area, which is here. Ironically, they've drawn it in this direction instead of this direction, but this uses exactly the same MP-7741 chip. And probably the reason why in ham radio outlet, when I was examining the 7300 and its frequency was so much higher, probably one thing I didn't notice was the power supply voltage that ham radio operator was running at. Of course, I was running at a voltage of 11.9 volts to get that ciphering at 700 kilohertz. And so they might have been running at 14.5 volts or something like that to get that up around 800 kilohertz or so. So that's what's happening. So L231 and 232 were here. And if I put a scope probe on the inductor, we could see that the switching frequency is 740 kilohertz right now. And if I dial up 740 kilohertz with this, you can tell it's not happy at all. And what I'll do is I'll go back down to 700 kilohertz, and I'm going to change the power supply voltage. Right now it's 12.8. Might not be able to see that, but watch this. As I change the power supply voltage, the frequency changes. eventually I get down to 705, and the reason why you see it move is because it's having to do that to operate the speaker. But yeah, that's the problem though. It's the PWM power amplifier that they have operating the speaker and the external speakers. So all right, well, here's the final modification that I've done. Basically what I've done is taken the power amplifier, which is this PWM power amplifier, and I have severed some of the connections here, as can be seen with the red X's. I've just taken a small razor blade and cut these connections so that I can restore them in the future if I ever wanted to. But this way I didn't have to remove the chip. Sometimes it's hard to remove these chips. It's got a power pad on the bottom. Hard to remove these chips without affecting the components around it. So I've severed the connections as shown here to bring out 5 signals: input, enable, power, ground, and out. And what I've done is I've taken this here, an LM4950, and this is a stereo amplifier, but I just connected the output to the input on this one. I'm just using channel A here. I've just got it with a flying lead here with the ribbon cable, and we get real lucky because the power pad is actually grounded on this thing. So here it is. There's no more oscillation around 700 kilohertz and various multiples thereof, which makes sense because I've completely, by severing the power connection to the switching chip, I have completely stopped this thing from switching. And so what I'm going to do here is, let's see, I'll try to remove this. So this board here, there's an area here right there where they had this orange pad, and this orange pad was down there, and all that does is it kind of contacts this to keep the board from rattling. What I'm going to do is tuck this little power amplifier under the orange pad so the orange pad can hold it down to the case here. And like I say, we luck out because this is all ground, this is ground. Every one of these copper pads here gets screwed to this, so I'm not doing any grounding that I shouldn't do. So so that's going to be the final resolution on this. It wasn't too bad. It's not the easiest mod I've ever done, but it wasn't too bad. As you can see, you got basically five pins on a ribbon cable. Probably the toughest part's going to be making sure that thing gets tucked under there and stuff like that. But yeah, all in all, not too bad. And I kind of lucked out here, was able to get this from DigiKey with 1-day delivery, and so being able to get this thing fixed up pretty quickly.